Okay, folks, we talked about the side angle side condition, or briefly in class today. This is what we're going to be using, one of the situations that we're going to be using for the law of cosines. Remember, I talked to you about whenever you're looking at a triangle situation, the first question I ask myself is it a right triangle? Well, the answer to this situation is no, it's not going to be a right triangle, so I can't use SOHCAHTOA. The second question I'm going to ask myself from section 5.4 on the law of sines is, does it have a known angle and a known opposite side? In this case, no, it will not. So I can't use the law of sines. So I also talked to you about how this would be the big gun. This would be the law of cosines is the last resort. This is what we're going to use in order to solve these situations. And I tried to review with you a little bit in class about the Pythagorean theorem. And in the Pythagorean theorem, which you're very familiar about, there's more to the Pythagorean theorem than we ever really shared with you before. Kind of like we hid some things from you, and now we're going to tell you the real truth. And what we were hiding was the fact that the Pythagorean theorem was really a specific case of the law of cosines. There's this extra term, minus 2ab cosine c. We talked about how the capital letter represents an angle measurement. The lowercase letter represents the side opposite that. In the Pythagorean theorem, the most important choice you have to make is which side of the right triangle is the hypotenuse. And we put that side over here on this side of the equation. Well, I guarantee you in the law of cosines that your decision about these two things right here, side C on the left and angle C on the right, will be the most important decision that you have to make. Not only do I guarantee you that that will be the most important decision of the whole process, but I also will guarantee, if I can spell it right, that one of these variables, or one of these, will be your variable. Either side C is going to be your variable, or angle C will be your variable. But one of those is going to be your variable. Now, let's take a look at this particular situation. You have, you're trying to find side X. It is opposite angle 140. It's not a right triangle. There's not a known angle and a known opposite side. I told you my most important decision was deciding these two parts of the equation. Angle 140 is opposite side X. Right there's the most important decision I have. I need an 85 and a 90, an 85 and a 90. It does not matter in which order you put them, as long as you have one of each here and one of each here. Now this shouldn't be too terribly difficult for you to solve. All of this you can calculate with your graphing calculator, so let's do that. $85 squared plus 90 squared minus 2 times 85 times 90 cosine 140. Please make sure your calculator is in degree mode. Otherwise, you will not like the results. 27,045.48. That's the value of x squared. So how do you think we're going to solve for x? That's right, we're going to take the square root. 164.46. My next question for you. How do you solve this? Well, I'm pretty sure most of you would add the 5 and the 2 and get 7. I'm really hoping and praying that there is none of the students out there in the universe that would take 7 minus 3 and get 4 times x. You wouldn't do that to me. You wouldn't do that to your teacher or yourself, for crying out loud. Hopefully not. Hopefully you would subtract 7 from both sides, giving you 3 equals negative 3x. And then using your powers of division, which you got from the eye doctor, you would divide and end up with x equal to negative 1. Okay? And a great hallelujah would come from the heavens. Now, I need to use the same logic over in this next question. I know you're probably wondering, well, why did he do that simple little pre-algebra equation over there? Because a lot of you in this situation think that these two things can go together. Now, you say to me right now, no, Mr. Staley, I would never do that. But then when it comes to reality, you decide to do it, and it hurts me to the core. Gets me right there in the heart. I have to pull the dagger out of my chest. Alright, look at that. Not drawn to scale, moo-ha-ha. That's hilarious. Wonder who wrote that. So anyway, you got angle x, angle y, angle z. Lowercase x is 10. That's the side opposite angle x. Lowercase y is 15. That's the side opposite angle y. Lowercase z equals 20. That's the side opposite angle z. Keep in mind, it's really important. Capital letters are the angle measurements. Lowercase letters are the sides opposite those. So in a question like this, where you're given all three sides, we want to find the measure of angle x. First of all, is it a right triangle? No. Is there a known angle and a known opposite side? No. So I've got to use the law of cosine. So the most important decision, what are we going to use for the equation at the very ends? Well, it looks like these two are across from each other. One of them is what I want to know, and one of them I already do know. So that's what I'm going to use. Side 10 goes over here. Angle x goes over there. And then it doesn't matter what you call the other ones, right? You need a 20 and a 15, and a 20 and a 15. Now, the solving part of this equation is where it gets kind of tricky, and I want to work through this with you. There are really 3 steps to solving this equation. The first one involves this sum right here. How do I get this to move to the other side? You subtract it. Same thing you did in that little simple example I gave you a few minutes ago. So what do you do to get this to move to the other side? It's being multiplied times cosine x. Wouldn't you divide? The only difference between this question and that simple little problem was this over here. How do you get rid of that? Cosine inverse. So here are the 3 steps. Okay, let's show them to you on my calculator. Same way I would do them. 10 squared minus parenthesis 20 squared plus 15 squared. Okay, so I'm going to subtract that whole chunk to the other side. Gives me negative 525. Then I'm going to divide by the next chunk. Negative 2 times 20 times 15. Use parentheses around these chunks of information that you're taking to the other side. That way you don't make a mistake. So the cosine of x is equal to 0.875. And we can invert the cosine to find my answer. 28.96 degrees. So we subtracted, we divided, we inverted the cosine, and angle x was approximately 28.96. If it makes more sense to you to write out the individual steps with the individual numbers, then do it. Just because I showed you kind of an easy way to subtract and divide and invert the cosine, if you need more for your own sanity's sake, please You're the one taking the notes. Just show your work. Show the work on what this number is. Show the work on what that number is. There's no harm in that. Okay. That's enough for the law of cosines. If I were you, my suggestion would be look over 5.1, 5.2, and 5.4. Pick some problems out. Okay? You're getting to be more adult-like all the time, so you better make more adult-like decisions. That means if you're going to get ready for a test or a quiz, pick some problems and practice. Bring them to class so you're ready to ask questions. So I can help you. So just start taking some responsibility for yourself and practice some of the questions. Don't pick the weirdest questions you can find. Alright? But make sure you're picking problems so you know how to use the law of sines and cosines and SOHCAHTOA. Okay. Talk to you in class.